Hello everyone, welcome to this video. Let us continue in this video with the properties of the group G4. So let's see another striking feature of D4, dihedral group of order 8. Here every element of D4 appears exactly once in each row and column. Now this is one of the observation that we can make. Here you see you have no element which is repeating in a particular row or in this row or in any other row, and moreover you also do not have any other element which is repeating in any of the column. There is no element here which repeats, there is no element here also which repeats. So this is true for all the rows and all the columns. So this forms the fourth striking feature of this dihedral group D4, right? This feature is present in all groups which have finite number of elements, for which you can create a table of this kind, Cayley table of this kind, and moreover, while constructing this table, Cayley table for any group, you should also remember and take this property into account, right? So that would be an easy thing for you to create the Cayley table. Moving further on to the fifth property is that of commutativity. Now what is this commutativity? You can also call it to be the abelian property of the group, or if it does not hold, then you can call it to be the non-abelian property of the group. So now this property is not an essential property for any mathematical structure to be a group, right? So this is an additional property. So here any group could either be abelian or non-abelian. Thus this is based on what condition? It is based on the condition that if you take any two elements A and B, then when you apply the operation that is given to you, in our case we are given D4, and the operation that is given to us is that of function composition, then if AB is equal to BA for two elements A and B taken from the element, then we have the property of commutativity. Now what does that mean? Let me tell you exactly by taking the example of D4. In D4 you see what is H composed with D. So what is H composed with D? So here you have H, right? Here you have D. So their resultant is R90. And what is D composed with H? So you have D here and you have H here, right? Their answer is this one. It is 270. So you see this R90 and 270, they are not equal to each other. So therefore HT is not equal to DH, right? This is one thing. Another example that I've listed here is that of R90 and 180. So let's see what does here happens when you take R90 composed with R180. So you see here you have R90, here you have R180, so you have the answer as R270, right? And what about this R180 composed with R90? You have one R180 here and R90 here, so you have this as R270. So you see in this case your R90 180, that is equal to R180 R90. So that means I'm saying R90 R180 is equal to R180 R90. If that is so, this element is commutative. These two elements, however, these two elements, they are not commutative. So from here, if we have the commutativity in any of the case for all the elements which are present in a particular set, then that particular group is called a commutative group, or in other words you could call it to be an abelian group, right? So let me show you what I have written here. So as I have told you, in D4 both HT is not equal to DH, but these two, they are equal. I have shown this property for by taking two examples. You can take more examples also. Thus in a group, whenever you have AB as the same as BA, then you call that group to be commutative or abelian. if that is not there for every element, it could be true for some elements but not true for other elements, then you call that group to be non-abelian. Now why we are okay with the word commutativity, but why do we keep using the word abelian? This is new to us. So the reason for that is this word came from the name of the great mathematician Niels Abel, who gave this concept. So from this Abel here, we are writing it down as abelian, belonging to Abel, right? So this is the property of commutativity. And you can see another property of the group D4, it is associativity property. Now this property is an essential requirement for any mathematical structure to be a group. Now what is this property? So if you take any three elements from the given set, right, for that you should even if you solve AB and then solve it with C, or you solve BC then solve it with A, they will give you the same result. If that is so, you have the property of associativity for all elements, right? If that is not so, then if it is also not true for one of the element also, then also we do not have the associativity. So for D4 we wanted to check whether it is associative or not. So that means we have to check it for all the three elements which are the member of D4, right? So basically what we are checking, we are going to check, suppose we have one element as R0, another element as R90, or you say 180, and another third element as say D. So we wanted to check whether this thing, is it equal to R0 composed with R180 and D. Both of them they are same or not. This is done for one such combination. Now how many such combinations would be there? You have in total 8 elements and you are taking 3 elements from those elements, right? So how many possible combinations would be there? 8 to the power 3. So that means 512 in total. So that means you have to check this equation, this particular equation here for 512 elements. So that is not really usually done, right? Because it would be so time consuming. So in fact we will take another approach here. What would be that approach? That in order to check D4 is associative, we will see we are talking about 8 motions of the symmetry of square, and which are functions, right? And the operation that we are taking is function composition, and in the lower classes we know function composition is associative in nature, right? Because if you compose f with g with h, then this thing is equal to, if you compose f with g first and then with h, this thing is there whenever you compose 3 different functions. So because this thing holds for function composition, so therefore we have associativity for the group D4. So that means these are the various properties for D4. So you see what are the essential properties which are required for any group. In this video we were particularly talking about dihedral group. So you see we require the property of closure, we require the property of identity, we require the property of inverse, and we require the property of associativity. If all of them happen together for a particular set together with a particular mathematical operation, then that mathematical structure forms a group, right? So we were talking about dihedral group of order 4, in which we were talking about the symmetries of a square, right? We were performing the rotation and we were flipping it through various directions. So we also have dihedral group of order 2n, where so this is some general group, right, where n could be anything greater than or equal to 3. So we denote this by d2n, right? And it would be it would give you the symmetries with figure which would have n such sides, right? Because you can for D4 you have the order as 8, right? So for 4, because we were talking about square, it has 4 edges. So therefore in this case we would for example, if you take n as equal to 3, we are talking about equilateral triangle. So we are talking about the symmetries of equilateral triangle. So this would be a dihedral group having order, how much? Having order 6, right? And you would write it as D3, right? Similarly, you could also talk about the symmetries of regular pentagon. You could also talk about the symmetries of any irregular hexagon, septagon, octagon, and so on. So in general, we write this to be dihedral group of order 2n, and we denote it by D2n, and the procedure for checking it to be a group is similar to one that we have performed by for taking the symmetries of a square, right? So I hope you you got a pretty nice idea about what is a group. So we'll be talking about more formal definition of groups later on, right? So and moreover, we saw a detailed example of this dihedral group in order to understand what are groups. So I hope you understood this concept. Well, that is it for this video. Thank you for watching.